Welcome to episode 2 in our series Concept Before CAD. I'm Brian Zayas. Now last week we took a look at designing a wall-mounted monitor arm from scratch using SOLIDWORKS Mechanical Conceptual. Now that idea sparked a whole other tangent that we're going to look at this week. Let me show you what I mean. For example, I'm always using my whiteboard. I'm going to use it for planning, meetings, note-taking, whatever I need to do, but one thing I hate is that weird angle that I have to draw at. What if I could bring my whiteboard off the wall, draw on it like a drafting board, but then put it back up to show others? This is the idea that I posted to our community, and this is where things really got interesting.
So I saw Brian's post to our online community about his idea for a movable whiteboard mount, and I wanted to get started right away in Mechanical Conceptual. As it turns out, we went in completely different directions with our designs, but we both had good ideas. So to get started, I'd like to walk you back through my initial concept. My colleague Michelle was telling me how his daughter likes to come to his office and draw on his whiteboard, except that it's too high for her. Using the built-in instant messaging, Michelle was able to send me a 3D snapshot from his screen showing me how he'd like to be able to raise and lower his whiteboard. I have an idea for a high-friction belt drive linear actuator that might help Michelle raise and lower his whiteboard. I'll draw 2 circles to represent the pulleys. To get the pulleys to move together, I'll define a belt. The drive ratio is determined by the actual diameters of my pulleys. Now I'll sketch in a bracket that will travel along the belt. A rack and pinion relationship defines how the bracket attaches to the belt. With just a simple 2D concept sketch, I've been able to capture my idea and test the range of motion. I'm now ready to start building physical parts from my concept sketch. Mechanical Conceptual recognizes each object in my sketch as a potential unique part. If I want to make any object 3D, I just touch and drag. I don't have to extrude every part to visualize the motion in 3D, but I would like a more detailed motion study, so I'll attach linear motors to define the exact range of travel. Now that the mechanism is working, I'll sketch in a rectangle representing the whiteboard and extrude it as a simple 3D feature. The single modeling environment allows me to work interchangeably with features, parts, and even sketches, because in the concept phase, I may not yet know the final assembly structure. Sketches and features can be effortlessly turned into parts, and their relationships are automatically mapped to 3D mates. Mechanical Conceptual makes top-down design a breeze. Michelle, I hope you like what I've come up with.
The articulating whiteboard mount that I'm thinking of is actually a variation on a 4-bar linkage, which of course is a snap to draw out in my 2D mechanism sketch. I'll draw in the links, and I don't know my dimensions exactly yet, but what I can do is add in sketch relations. So for example, I'm going to add parallel constraints to these 2 sets of linkages, and that way I'll get that accordion style motion that I'd like to bring it in and out of the wall. I'm going to bring in a whiteboard and center it on the mount, and then go and just drag it to test the range of motion. Now, when it's fully open, I think I would like to have this thing be about 40 degrees. That's going to be appropriate. And then of course in the fully open position, I want to optimize that gap between the edge of the board and the wall, maybe about 1.5 inches. What's great here is the links are updating their length as I adjust that. Set up a quick motion study just to animate and see what this thing looks like, and it looks pretty cool. I'm going to add in one more link. This is going to be a horizontal bar that's going to add in stiffness, so when I draw on the whiteboard it's going to be rigid enough. I can draw it without knowing the length in advance. Of course, just add sketch relations, tell the software I want it to be horizontal, and now it can drive the rest of the lengths of those linkages. One last check of the motion study, and now let's go ahead and post on my community. I'm going to reply to my own thread, and I see Brad's comment real quick, but I'm going to add in my idea here too with the articulating 4-bar linkage. I'll post that and see what Brad can do with this.
I got a notification that Brian posted to our online community where he's attached a snapshot of his design with his comments. The social tools in Mechanical Conceptual are great for documenting the conversation history of our design reviews, and I think I know of a way I can combine the best parts of both of our designs. Since our design data is always available online, it's easy for us to collaborate. Concept archives provide snapshots of different design iterations. I can retrieve Brian's original mechanism sketch and branch off a new design concept. If I change the hinge connection on this bottom link, now Brian's linkage mechanism has the vertical mobility that will allow it to attach to my belt drive actuator.
Brad, the vertical belt drive motion is great. I'm going to adapt it in my office to use a couple of linear rails. Now here's the best part. That's exactly the motion I was looking for. This might be as good as chocolate and peanut butter.
With Mechanical Conceptual, it was easy for me to take the best parts of both designs, so we could give Michelle the vertical motion that he needed, but also give you the lateral articulation you required for your application. But Brian, it looks to me like you've taken that design a step even farther.
Yeah, absolutely, Brad. Now that we have the concept working, we could actually bring this into SOLIDWORKS, get our detailed design, and start specifying our off-the-shelf components, and heck, even motorize this thing. Why not? Well, thanks everyone for joining us for episode 2, and next time we'll get into some more design challenges that we find around the office. Thanks for watching. We'll see you next time.